I'll just say that periodically during the day so people will applaud. This is you can feel the atmosphere is charged. You can actually hear the jingling in the background. It's a very special day, a very auspicious day. We are honored to have with us here today a panel of four important engineers, my personal heroes when I was growing up. I was only 14 when you all did the miracle back in 1969. I tried very hard to get here and follow in your footsteps as quickly as I could. We have a panel that's going to talk about Lunar Module Landing Operations today. And if you want to know what that is, they'll tell you about it as we go around. We have the panel here is Jack Knight to my immediate left, Bob Nance, Hal Loden, and Bill Reeves. And instead of me going on and on about them, I'm going to ask them each to identify themselves briefly, say a little bit about what they did, and then open it up a little bit for questions. And by the way, since I didn't introduce myself, my name is John Charles. I'm the scientist in residence here at Space Center Houston. So I'd like to turn the microphone over to Mr. Knight to talk a little bit about what you did here for Apollo 11 and what brought you here in the first place and your recollections of that important day.
Okay, I was the son of an Air Force family. We're in various bases around the world. I went to Georgia Institute of Technology and graduated in 1965. I came directly here to the Manned Spaceflight Center and was hired by the operations area, and in particular the Apollo Systems Group. At the time I arrived, Apollo had been as a program in work, but we were flying the Gemini and Agena vehicles. And I was in the environmental control electrical power area. I participated in every lunar module flight, including the first unmanned one. And I was in the SSR, staff support room for that. And on all subsequent flights, I was in the mission operation control room in positions we called telcom or telmu, depending on which flight we were talking about. So that was Apollo 9, 11, and everything that had a lunar module on it. And I'll pass to Bob Nance.
Good morning. This is a big day. I started this morning with a prayer just like 50 years ago. Lord, please help me not screw up today. My name is Bob Nance. In 1962, I heard President John Kennedy tell the world that we were going to go to the moon by the end of that decade, and I wanted to be a part of that. And everything from then on went on. I also went to Georgia Tech, and I met astronaut John Young there, and through him ended up here at from Georgia Tech to then the Manned Spacecraft Center in lunar module propulsion. I was so blessed that I got to absolutely live my dream of sitting on the console as lunar module propulsion when we landed on the moon. I think we'll talk a lot about that later.
Well, good morning. My name is Hal Loden, and a little bit about my background. I grew up in Texas, moved around a lot. My dad was a Methodist preacher. I was in Florida working on a space program for LMTC at the time, 1963 to 64, which was a Langley project, and the manager of that was a good friend of mine, and he said, well, why don't you go to Houston to Manned Spacecraft Center? Well, I'm from Houston, my wife's from Houston. I said, well, that'll be great. So I got a job here at JSC, or MSC at the time. Went into the operations directorate, and then I was at the Gemini Agena systems. Back up just a second, I'm an electrical engineer by education from Texas A&M. Whoop! Anyway, during Apollo 11, I was a flight controller in the Lunar Module GNC systems division, or systems area, which that area comprises of the descent and the ascent engines, the attitude control systems, the landing radar, the rendezvous radar, and the hardware for the primary and backup computer systems. And I flew all the Apollo missions from LM 1 I was in a remote site out in Carnarvon, Australia for that. Apollo 9 through 10 and 11, 12, 13, all the way through 17 was still in flight in the mission control for the lunar module. Specifically on Apollo 11, I was the limb control guy on console for the ascent from the moon. The descent was exciting. I was there sitting behind our good friend Bob Carlton, who did the descent that day. He's no longer with us, passed away here a couple of months ago. But, I was a little hesitant as to whether we were going to make it or not when Bob was calling out the fuel remaining, because we didn't have a lot left, did we? But, when I got on the ascent, we had problems too. And I hear people say that the ascent was more risky than the descent, and I find that hard to believe. But anyway, that's my story, and I'll pass it over to Bill Reeves.
Good morning. My name's Bill Reeves. Is this working? Okay. My name's Bill Reeves. I grew up in Arkansas and went to Oklahoma, OU, to get an electrical engineering degree and wound up here in Texas as fast as I could. So when it came to football season, I didn't have a chance growing up in Arkansas and OU and Texas. But anyway, when I hired on in 1967, I hired on into the flight operations director at Flight Control Division, and as a flight controller on the lunar module in the electrical power system group. And we were in charge of all of the power systems and the power distribution systems of the lunar module. And we also were in charge of the pyrotechnic systems, which are the explosive devices that separate the stages and open valves and do that kind of things, deploy the landing gear. And so I had gotten here right after the Apollo 1 fire, which happened in January. So the program was in a delay while they figured out what had happened and redesigned and got back flying again, which turned out to give me the time I needed to get on board, and was lucky enough to be in position when we started flying the lunar module. And so I was in the staff support room, which is the support rooms are the rooms that support the main control room, and we're the people that made the people in the main room look good. So, when you see the control center, when you go over and see the control center, and when you see it on the movies and everything, that's the tip of an extremely large iceberg. There's a lot of people supporting that. And then I was flight controller on the lunar module throughout the entire Apollo program for all the flights. And then after Apollo was over, I flew backseat in NASA's high altitude airplanes for about 8 years. And then came back to operations for shuttle and was a flight controller on shuttle, and then later selected as a flight director for shuttle for 22 shuttle flights. And that's it.
This is excellent. This is a very good thumbnail sketch of the lunar module activities for Apollo. I am derelict in my moderator duties. I forgot to tell you when we first came in that when we're finished here, not now, but when we're finished here, please move quickly to the exits. There's 200 people more outside waiting for the next presentation. So with that out of the way, I'd like to ask a couple of questions, and we'll open it up for a Q&A from everybody else. I would like to talk about the two significant lunar module propulsion activities, events of any mission. One is the descent, the powered descent, and one is the powered ascent. I'd like to start with Mr. Nance and talk just a little bit about your recollections, any trepidations you had, any confidence you had about the lunar landing, the powered propulsion down from lunar orbit, and your recollections, your thoughts about the probability of success, the inevitability of success, or any sweaty palms you might have had.
Yes, there were a lot of sweaty palms. That is a broad area, but let me try to give an overview. First of all, the lunar module descent starts shortly after the lunar module comes back around from the backside of the moon. The big surprise we had, and I think Jack mentioned it in the previous session, that the data was so difficult that we were having trouble getting voice and data, in particular high gain data. And as we started the descent and the engine fired, the first thing that happened was that the data dropped out. So we're sitting here giving go, no-goes without any data. I know a lot of times you hear the landing and it sounds like everything went really, really smooth, but it was difficult at the beginning. The data would drop out, we'd get a little bit of data, and okay, everything's working good, and then we got our data back, and then we came to the yaw. That's where the crew starts off with their head down so they can see the lunar surface. As they're starting to lean over, they rotate, actually yaw, they call it, 180 degrees. And when that happened, we lost data again. So at first it seemed, are we really going to be able to land like this? But the great news was we started getting good data. Everything was looking good. We did hear that we were going to be long. We knew that from the very beginning. That had to do with a slight timing error, I think, when the burn started. But everything was going very, very smooth. One of my jobs, and I was likewise, I should have mentioned before, I was in charge of the ascent engine, descent engine, and the reaction control. They are those thrusters that you see out on the lunar module out there. And a lot of people think, wow, you're just concentrating on the descent engine, but we actually had to have a visual pattern where you looked at the ascent and the RCS, because you're burning an engine, the vehicle is shaking. You wanted to make sure that if the descent engine was working good, whether the ascent was springing a leak or something was bad happening there. So even though you were concentrating on the descent, you constantly had to look at the other systems in the various propulsion systems. We start off burning at about 98% thrust, and then it drops, and it dropped at 6 minutes and 25 seconds. By then, we had data. Everything was looking pretty good. Everything is just tracking. We had a few computer problems that you heard about, an overload on the computer, the 1202, and later a 1201. But everything seems to settle down. Everything was going good. One of the things that we were always a little worried was that our fuel margin on this first mission, it was running about 4.5% propellant remaining. It was looking pretty good. Then we heard attitude hold. Attitude hold is when the crew decides to take over themselves. Normally, if they did nothing, the limb would actually come all the way down right to the moment just before landing. We already knew from simulations and that we did with Neil that he'd like to take over early, but this is way earlier than we normally had ever seen. So we knew that something was going on. One of my jobs was, of course, the propellant monitoring. Are we going to run out of fuel? So we had sat in a meeting with Neil and Buzz and worked out what we were going to do. We first had an indication of low level, that is 5.6% propellant remaining. We knew that. The goal was, at that time, you knew approximately how much time you had to hover. Well, to be honest with you, when we got to 5.6, they weren't anywhere close to hovering because Neil had realized he had to go down over top of a crater and get away from a boulder field and to try to find some smooth ground to land the limb. We could see this happening because the RCS, those little jets, normally the descent engine has a bell and it moves to control, so small motions are made with it. When you see the RCS, that means he's overriding it. He's putting in a command that's greater than the descent engine can move that fast. So he had leaned over, going forward to speed up. Well, he stopped descending. Actually, he went down and actually went up a little bit. I'm sure that was to see where he could find a clear spot to land. Then the next call was 60 seconds. That's 60 seconds till you run out. That's not 60 seconds that you have to make up your mind. The calls were 60, 30, and bingo. 60 seconds, 30 seconds, and bingo. And as I mentioned in a meeting, we sat there and my original idea was 60, 30, and 15. And Buzz was, kind of talked right much and was really pretty active and everything. And Neil was always very quiet. And after quite a while of talking about this, all of a sudden Neil says, I don't like abort because I'm a pilot. and I'll make that decision. And I said, we know that you will, Mr. Armstrong. And so he turned around and he said, can y'all give that another name, please? And I believe Buzz was a Navy pilot, and he says, well, an aircraft carrier, when you are committed to land, you have to land no matter what, you say bingo. And so Neil said, bingo works. So it was 60-30 bingo. The problem with that was I never expected to call 30. In simulations, we normally landed shortly after 60 seconds. Actually, I have a website. It's called robertnanceapollo11.com. And I have all of those tapes. You can actually hear the SSR talking to control. And when I made the 60-second call out that was passed on, it was 60 seconds. When I made the 30-second call out, it was more like 30 seconds. Like I didn't believe it was good. I couldn't believe it were here. The final number, after a lot of analyzation, was we landed with 22 seconds of fuel remaining. In addition to all that, we had a problem with slosh, but that's another story for another day. But the interesting thing about this is that I think it's really important that the public understand just how brave Neil and Buzz were. I mean, there were so many things. People don't realize that. They think, well, we sent other missions there. This was the very first time we had ever landed any spacecraft like this. All the other missions, as you've heard about, probably heard about, Ranger and Surveyor landed directly. You couldn't do that with men on board. If anything happened, you had no way to stop it to start back up. The Ascent wouldn't have enough propellant. So we landed it totally different by starting in orbit and going down slowly. And this is the first time, and these computers that have very little memory, this is the very first time that was ever done. And I just, if you want to applaud somebody, you applaud Neil and Buzz. It was amazing.
Thank you. And skipping over an awful lot of interesting stuff that I'd like to ask Mr. Loden about the Ascent, about the powered Ascent back to orbit. And if you could say just a few words about the unique characteristics of the Ascent propulsion system.
Okay, let's see what I can come up with here. 50 years is a long time ago to remember all the details. As you remember, during descent, we had those 1202, 1201 alarms that gave everybody a lot of concern. And that was because the onboard computer was being overloaded doing tasks that it really didn't need to be doing. It had to do with the rendezvous radar, trying to keep track of where the CSM was and that kind of thing. Well, so when we came to Ascent, there was quite a few crew checklist changes that had to be made to take into account that potential problem again showing up possibly on Ascent. We did not want that to happen. We wanted to keep those alarms from happening. So one of the changes were made that we just came up with a procedure to stow the rendezvous radar antenna and to power off the rendezvous radar during Ascent. There was another issue that I remember working. When they came back in from their EVA, Buzz noted the circuit breaker panels, there are circuit breaker panels on both sides of the lunar module on the inside. And the circuit breakers are not like the circuit breakers you have in your house where you flip it like a light switch. These are circuit breakers where you push in and pull out. Well, these circuit breakers, most of them were already out, which was in the off position. And he noticed, once he got back in the lunar module, a circuit breaker was broken off. It happened to be the Ascent engine arm circuit breaker, okay? Now, that doesn't mean we're not going to be able to light the Ascent engine. We have two ways of doing it. That one allowed the computer to automatically light it. We had a manual way to work around that with another push button. So he was trying to figure out what to do. So as I understand it, he took out his trusty government issue black ballpoint pen, pushed it in. okay, during the countdown at the right time for Ascent. The other thing that occurred leading up to Ascent, on the Ascent propulsion system, the fuel tanks, we had 2 pressurization bottles for redundancy to pressurize the fuel tanks to get the fuel all at the right pressure and everything before it goes into the thrust chamber of the Ascent engine. And normally during the simulations when we did this, these were pyrotechnically operated valves to open the tanks to pressurize the fuel tanks. Normally during simulations, we would always see both of those tanks drop a couple of PSI, or PCM counts is what we called it. And so that would confirm that both valves had opened. Well, when it came the time to really do it on the lunar surface, and they fired the valves to pressurize the Ascent engine so they could lift off, I only saw one bottle drop. I did not see the other bottle drop, which said there's a possibility we've only got one bottle of pressurization on our fuel tanks. Part of the normal procedure for Ascent was assuming you had both bottles, and we had a system interconnect between the Ascent engine and the reaction control system, the thrusters that Bob was talking about. They had to both use the same propellant, and we could use the Ascent engine propellant out of its tanks to also fire the attitude control system jets on the way up. But if we only had one bottle of pressurization, we had to terminate that interconnect. It's called Ascent feed. So we had to alert the crew before liftoff that that was a possibility, that if really and truly we only had one bottle that would pressurize, then they'd have to terminate Ascent feed on the way up. So the countdown to T0 was done by the computer. The procedure also called for shortly after takeoff, they were to hit this engine fire override button, which circumvented the command coming out of the computer just in case the computer-owned command went away for some reason, the engine would still stay on. So at liftoff, a few seconds after liftoff, I told flight, yeah, we've got both bottles. I saw the other bottle starting to drop in pressure, so I was very relieved about that. And to tell them, continue on with Ascent feed. And from then on, I noticed that they had not hit the engine fire override either, the second way of keeping the engine on. So I had finally, about halfway up, they finally energized the backup route for keeping the engine on. So those are the things that occurred for me during the Ascent. As far as the Ascent engine, it was about a 3,500 pound thrust engine. It wasn't very big. It was about 4 feet tall, about 3 foot in diameter. No big deal, At the Ascent stage weighed about 10 or 11,000 pounds. So it did its job very well. And if you'll notice on the films of Ascent, when they're looking out the window, you see it kind of rocking back and forth. That's within the deadband of the attitude control system, and that's what the attitude control thrusters are keeping it within that deadband. The Ascent engine was not gimbable like the Descent engine was. So once we got back on orbit, they docked with the command service module, got back in the command service module and discarded our Eagle, which impacted on the moon after they left the moon. So it was a very good engine, very reliable engine. It did its job. I was very grateful to be a part of such a great event. Thank you.
And before we leave that topic, I do want to drill down on one point, and that is, how many test firings did the Ascent engine have before the flight?
That's a question I do not know the answer to. I would assume that it had gone through a lot of test stand firings, as well as probably some in vacuum chambers as well, just start kind of things. But both the Descent and the Ascent engines were thoroughly checked out before. The Descent engine with the throttle capability, that was a new capability that we'd never had on a spacecraft before. So the people that put these machines together were very dedicated. And that's a part of the iceberg that Bill was talking about a while ago. those people that built these spacecraft and the components that went into those spacecraft, those are the ones that made it happen.
And that wasn't a gotcha question. There's a very particular aspect of this I'd like to just let you all know about.
This is not my area, but I have read quite a bit of things over the years. And it's part of NASA's development process. When they felt there was an area that was highly risky, they would hire 2 contractors to work on it in parallel. So there were 2 different contractors that worked on the Ascent engine. And finally, you got to the point where one of them was more successful, or at least successful enough, and so NASA said, okay, you're it. You can go build Ascent engines. One of the things about the Ascent engine was, at least according to I read, is that its injector was such that erosion during a firing was so bad they could only fire it once. So they did a lot of testing until you certified that, but after that, no Ascent engine was ever test fired before it was ever used for actual launch. Decent engine is probably a different story, but that's the interesting story on the Ascent engine. But it was a very, as I said, it's a simple engine. It was a hypergolic fuel, so all you had to do is get them to mix, and it would work. And we knew from testing that it would work at least once. and that's all it had to work.
That's a good point, Jack, that I had not remembered. That first time we lit that sucker was on the lunar surface. You know? That is pretty risky when you think about it, isn't it?
You know that I was in a meeting with Neil. I think actually it was a debriefing from one of our simulations. So we didn't really love those. Those were sometimes difficult where we missed a problem or something. But I remember Neil saying is, why in the world didn't we just put a big lever on the side? Because the actual top of the engine looked like a seat sitting in the middle of the lunar module. And he said, why in the world didn't we just put a big handle on it where you just turn it and it starts?
That would not necessarily work for an abort stage during the powered descent. So, yeah. Well, let me add another thing. Bob mentioned the loss of comm. When LEM came around the moon for powered descent, its engine was essentially pointing towards the Earth. So the S-band high-gain antenna had to point through the landing gear and whatnot to get to the Earth's antennas. One of the things that was added late in the game was the deflectors on the descent stage that were right underneath the down-firing thrusters. They were added late in the game because the thermal analysis said that there might be enough erosion caused by those thrusters that it would damage the thermal protection on the descent stage. So they put those little deflectors. Because it was very late in the game, those deflectors were never included in the modeling of antenna pointing and getting good communications. So the comm guys, pretty sure that's what happened, is when you started the descent engine, or as you were coming around, the antenna was essentially trying to point through one or more of those deflectors. And so we had Radicom until you moved the vehicle a little bit and reappointed the antenna. And because Neil wanted to be looking down at the moon, you had this other maneuver, the 180-degree turn he was talking about after he started the descent engine and ran it a little while, and then you had to roll it over, yaw it over, so that when it pitched forward, the Armstrong and Buzz would be able to see where they were going. All subsequent flights, the crew decided they didn't need to be looking down. They could just get in their anticipated position, and all the LEM would have to do then is pitch forward. You would not have to have a yaw maneuver. So that's probably why we ended up with the comm problems until they had pitched forward enough and moved enough across the surface that the LEM steerable antenna got good enough direct comm with the ground.
I'm glad you mentioned those RCS thrust deflectors. One interesting thing about that, like he said, this is the first lunar module that had them installed. And the reason they were installed is, like he said, that when the downward thrusters would fire, they would impinge on the descent stage and potentially cause damage. And as I recall, there was a limit placed on impingement of maximum of 15 seconds on the descent stage, or then we would have to terminate the flight. So these thrust effectors eliminated that problem, because on Apollo 11, it would have exceeded that limit according to the data analysis afterwards. So we would have probably aborted if we had not had those thruster reflectors on there.
I was going to say, there were a lot of great Neil Armstrong sayings throughout getting ready for this thing. And one of my favorite stories, but and all us old people remember things differently, but this is the way I remember it. We late in the game with the landing radar that was on the lunar module to tell you how high you are. There had been some problems in testing with the landing radar locking on at the distance it was designed to lock on at. So there was a lot of concern about whether it was going to be, give them the data they needed. And they had done a lot of testing on it, and we were in a flight rule meeting. I can remember it like it was yesterday. It was a very large room with a lot of people in it, and there was a big long white table with Gene Kranz was chairing the meeting, and Neil was sitting at the end of the table, and it was a discussion about developing a flight rule that said if the computer was not accepting landing radar data by X altitude, then it would be an abort, and the altitude would be a calculated altitude. And so they argued it for like 2 or 3 hours, and finally Gene says, "Okay, guys, that's it. We've talked about this long enough. That's the rule. If the computer's not accepting radar data by X altitude, calculated altitude, it's an abort." And everybody's nodding their head, and Neil was sitting at the end of the table and had his head in his hand and was just shaking his head, and all of a sudden Krantz saw him and said, "What's the matter, Neil? You don't agree with this?" And he said, "You must think I'm going to land with the window shades down."
I think that's the only mission rule meeting I remember.
I don't like to remember them because the room was full of nothing but smoke.
It was a different time then. We have time for a few questions from the audience. Anybody have any questions? And please shout it out succinctly, and I'll repeat it for the C-SPAN audience. Yes, sir, you. How far downrange did they land from the target site?
It was about 3.7 miles, but it was well within the ellipse. They were downrange and slightly to the left. And I did mention before, I was looking all this up in case you asked that question. I didn't know it a week ago, and I did put it all on a website. It's Robert Nance, Apollo11.com, if you want to look up that kind of stuff.
Yes, please. The question is, compared to the smartphone, how much computing power did we have back then?
Well, one picture on your cell phone has more bits in it than that computer on the lunar module.
Why did the lunar module carry jumper cables? Did you know it carried jumper cables? That might be one of those Wikipedia
I guess we had I guess we had die-hard batteries on board. We didn't need them.
Well, if our batteries didn't work, none of their stuff would work. So, no, there weren't any jumper cables. There were some cables that went between the command module and the lunar module during coast to the moon, where we powered some heaters in the lunar module for the 2 or 3 day trip to the moon, so that you wouldn't use any of the power out of the batteries that you needed for the lunar module on the lunar surface. And those are the only cables I'm aware of that.
And those cables, like Bill said, they kept the heaters going on our inertial measurement unit, the platform that you used to tell where you were in space and that kind of thing when you powered it up. But those cables came in to be very important on Apollo 13 because we were able to use LIM battery power to recharge the re-entry batteries on the command modules so they could re-enter safety.
Yes, sir, against the wall. Yes, sir. Why was the ladder so far off the lunar surface when they landed?
Yeah, the landing gear was, the original intent was it would automatically land, and when as Jack had said, that, and literally what was going to happen was that when these probes that were about 4 feet tall were to hit, it would actually shut the engine off and it would drop. We learned very quickly in simulations that that is not what Neil had in mind, and I don't think as a pilot I wouldn't want to have done that either. And so none of the Apollo landings were anywhere near as strong. But if the engine had quit up at 10 feet, the LIM, or 12 or 13 feet, it was designed to survive that fall.
It's going to survive by stroking the landing gear.
Yes, it had a honeycomb and would compress. And so you didn't want the ladder to stop it from compressing.
Yeah, there was no spring or anything in the landing gear. It was a honeycomb aluminum structure inside a tube, so it was just a one-shot deal, and it would crush and the strut would compress. But he landed so light that it didn't compress very far. That's why the ladder was as high as it was.
Yeah, who was responsible for picking and packaging and mounting the U.S. flag? And the top is straight because of the support arm. What about the bottom?
My recollection of that was designed by our Tech Services Division here at the Space Center, headed by John Kiker, and they came up with a concept of unfurling the flag with a support at the top and just let it hang in the lunar 1/6 gravity then. And that was all compressed into a small package before it was deployed. And I forget what, we fly one in our control center just like that. In fact, one of the flags that we have in the control center actually is now on the moon. I forget what mission they took it from the control center and flew it to the moon, but it's just like that.
During the practice flights with the lunar landing training vehicle, did Armstrong always have the equivalent of an excess of fuel at the landing? Do you know?
One of them, he didn't land. He ejected out of it.
I think that's right. I mean, the only ones that, you would leave for some other reason, or an engine problem, or a leak in the Ascent on the simulation. So we never really, the normal landings always had 4 or 5% remaining.
Yes, ma'am. Let me repeat the question, Mr. Reeves, first, for the audience that's not here in the room. The question was, it's called mission control, but who's actually in control? Is it the people on the ground or the people in the spacecraft?
Well, the control covers a lot of ground. The crew could manually control a lot of things within the vehicle, but what the flight ops team is constantly doing is keeping track of the flight plan and any changes to the activities that we're going to do, and any changes to any procedures that we're going to do, and working any anomalies that occur with the spacecraft. It's a joint effort between the crew and the ground. You're constantly going back and forth.
I would say,
in those days, we didn't have a lot of the command capability they have today. So you would put together procedures, read them up, and the crew would work through the switches. Where today, a lot of that stuff is done by command from the ground.
Well, let me ask you, are you meaning who's in ultimate command of making a decision? Is that what you're talking about also? Okay.
What- Let me ask, the ground computer complex did almost all the trajectory calculations and generated a set of numbers that were sent up to the spacecraft, which they entered into their computers. So without the ground, they would not have had enough computational power to do the whole mission. But once you got into powered descent, there was nothing the ground could do if the crew wanted to keep going. So if that's what you're talking about, that's how it, but if the ground called an abort, there's a very, most chances they would abort because they would assume the ground saw something they could not see.
I think another part of that is that in mission control, it's the flight director that makes, in a time-critical situation, that makes those decisions based on his team on the ground. In longer terms, he actually gets management that sits behind him, makes those decisions. But the overall decision of whether or not to recommend an abort comes from the flight director and goes directly to capsule communicator to the crew.
You know, there's 3 consoles in the control center that had the abort switch on it. Flight director, retrofire officer, and flight dynamics officer.
And that was almost always associated with a launch vehicle. And none of those abort
Launch vehicle,
worked
yeah.
for once you got out of
I think
forward.
we got time for one last question. Yes, sir. Oh boy, that's a whole nother seminar. That's a whole nother lecture. Can somebody answer that in 5 words?
My guess would have been the 1202 alarm, the first one, because it was just unexpected. It was not a normal thing. We'd done it in sims, but nobody really expected it would happen. And then because of the simulations had set up a situation, we had gone and did a bunch of research to figure out what alarms would be a real problem and what not. And Jack Garman had a list they'd worked out with MIT, who did all the programming on this thing.
Seems like the only time that Neil was nervous is when he said, "We need a readout on that 1202."
Again, unexpected.
Yeah, I detected that in the...
During the simulations, he had punched out. He had aborted when he got that alarm, but not, since we'd had all those discussions and reviews, he decided that it was okay.
You know, that points out that the real unsung heroes, there are just so many and so all over this country, but the simulations guys were just amazing. They had to not only learn the systems and how they worked and looked at our procedures, but then try to find areas. And in the very last sim, the 1201 actually came up, and that was the emphasis for looking into that. And that's just a perfect example of the teamwork that it took to pull this mission off.
Another way to describe the simulation people, they were very devious.
And on that note, ladies and gentlemen, thank you very much for being here. Thank these panelists.